Okay friends, so we are done with abstract classes for now, and let's study the second part of this chapter, interfaces. Okay, interface is a class-like construct, but not really a class because it only contains the constants and the abstract methods. And it works very much similar to the inheritance of abstract classes and otherwise that we have seen. So it's very much like a class, but it's not a class in itself. And it works slightly differently, which we'll see now. And it is useful because it is much similar to abstract class, but it just specifies the behavior of an object. Like if object is a comparable, some object is edible, some object is clonable, so it just lays down a kind of directive for a particular object, but it never specifies the behavior or the actual operations that are being done as a part of behavior. A class can have a couple of abstract classes and it can be abstract. But if all the methods of a class you want to abstract, uh, interface is a more preferred option, I would say. And you will see how in a bit. Interface declaration is very much simple. Public interface, interface name. Some constants and methods. Constants are very less used compared to the methods and signatures. So now signature is what I essentially called footprint in previous lectures. But we usually use interface for signatures. Now mind you, all the methods are abstract and hence they need to be implemented in the class which uses this interface. Okay, a class uses interface with a different operator. In if subclass wants to use a superclass, it extends the class, like we saw circle extends a geometric object. But shown in the example over here, if you want to use the edible interface, we won't extend it, we will implement it. So I can say class X implements edible, class Y implements edible, right? That's how it is used. uh, let's see an example now. But before seeing example, I'll just go through a couple of things. Okay, interface is treated like a special class in Java. Okay, it is compiled into a separate bytecode file, just like a regular class. So interfaces will have a bytecode file of its own. Okay, like an abstract class, you cannot create an instance of an interface using the new operator. Okay, and it is used as a data type for a variable or as a result of casting. Now we'll see how it is used in each cases, but essentially it's a special class which contains just constants and abstract methods, nothing else. Okay, for example, I declare an interface edible and I have a abstract method how to eat, right? So essentially, for example, chicken. Now chicken extends animal because chicken is a type of animal and it implements edible. So I need to define a method or which will tell me how to eat. So if it's chicken, then how to eat would be fried. Okay. Okay, let's do one thing. Let us build upon this example so the concepts of interface are impressed in a better way on you. Okay, and you internalize them pretty quickly. Okay, so we will write an example in Eclipse in the next part of this lecture. Okay friends, so now let's write some Java program which shows us the implementation of interface. So before I do anything, I'll need to write an interface, and let's write the edible interface that we just saw in our slides. This will give public abstract string how to eat. Right, this is my interface. Simple. Interface itself does not have any modifiers like class, right? We put public class, private class, protected class, but interface does not have any modifier. It can just work fine. Let me have a class animal. What should I put into it? Okay, let it be blank for a while. I'll have a class chicken which will extend animal. Okay, and it will also implement edible. Chicken is edible, right? We do eat. And hence I need to write the abstract method public string. I did not need to mention abstract keyword over here. Perhaps I did not tell you before. How to eat. It takes no parameters, and I return chicken. Fry it. Okay. Let me write one more class. Class tiger extends animal. Implements edible. Oops, tiger is not edible, so I remove this interface. Okay, let it be like this for a while, and this is good, right? But you know what, I'm a vegetarian, so let me have something for me. I have a class fruit, and it implements edible. Okay, and I need to write the public abstract method, which was how to eat. I want a hierarchy class apple extends fruit, and okay, I did not need to implement edible over here because my fruit itself implements that. Okay, let's do it this. I'll just create a class fruit without anything in that, and implements edible, and here I'll put my how to eat method public string how to eat return apple. Oh, sorry. Make cider. Okay, should be fine. And I'll also put class orange extends fruit implements edible public string how to eat return orange make juice. Okay, so I'm good. I want to keep it to this, but you know what, because apple and orange both need to implement edible interface, I'll make the fruit itself implement edible, and I'll remove edible from here. Okay, so this is good, but fruit shows me error because then fruit needs to define the method how to eat. I don't want to do that, so class is incomplete in a sense, and I will make this abstract, and that should just work fine. Oh, it does. Okay, so I think this is good. So now let me just quickly go over it what I did. I have just an interface edible. I have class animal and a class chicken which extends animal and implements edible. Of course, I can put abstract class edible, sorry, abstract class animal implements edible over here, just I did over here. But let me keep it like this for variety. And public string how to eat chicken, fry it. Tiger, you cannot eat that. Abstract class fruit implements edible, and apple and orange classes extend fruit. So now I hope you can understand this hierarchy, and let me write the class which has main function in that. Test interface, public static void. Okay, and what do I do now? Let me do something. Object array objects is equal to, I'll just create an array, new tiger, new chicken, new let's say apple. Okay, I'll run a for loop, integer I equals 0, I is less than objects dot length I plus plus if objects of I is an instance of edible. That means if an object is edible, okay, then I'll just system dot out, I'll just print how to eat it. Objects dot how to eat, I mean objects I, sorry. Okay, sorry, I forget to mention class over here, just in hurry. This is fine, but some error it is giving me over here. Let's see what is it. How to eat is undefined for the type object. Oh, I need to cast the object over here. I'm so sorry, I need to cast it to edible, because my method isn't edible, and I think that should be fine. Okay, okay, I'll just put a bracket over here to make it safe. Yeah, now it gets it. Let me run the program and see what it does. Chicken, fry it. Apple makes cider. Tiger, of course not, because it is not edible, right? This is the output I get. Let me make this smaller so you can read the program also. Yeah. So this was it. A plain simple example of interface. Okay. And before I finally close our discussion of this example, I want to tell you one thing. Even if I remove this modifier from here, it is fine. And even if I don't write abstract, it is fine, because with interface it is understood that all the variables will be constant and the methods will be public abstract. So this will work fine. I get the output, see. I do. So this is just fine with Java. Okay, let me just make a note over here. All the data fields are public, static, final. I hope you know this, because this is how we will use our constants in Java, and all the methods are public abstract. So these can be omitted very comfortably. Okay, so that was all about interface, I guess. Okay, and yeah, so we're good. See you in the next part of this lecture. Thank you.